Hello, and welcome to our video on geothermal energy. Geothermal energy is a type of renewable energy that has the potential to replace fossil fuels and help mitigate climate change. In this video, we'll explore what geothermal energy is, how it works, its benefits and challenges, research and development, and the potential for the future. We'll also provide a case study of a business that has successfully integrated geothermal energy into their operations. Geothermal energy is a lesser-known form of renewable energy that has been used for thousands of years for heating and cooking. But in recent years, geothermal energy has been gaining attention as a way to generate electricity, particularly in countries with high geothermal potential.
Geothermal energy is heat that comes from the Earth's core. This heat is harnessed through drilling and pumping water or steam from geothermal reservoirs deep underground. Geothermal energy is a renewable energy source that can be used for heating, cooling, and electricity generation.
There are two main types of geothermal energy: shallow geothermal energy and deep geothermal energy. Shallow geothermal energy is obtained from the uppermost layer of the Earth's crust, up to 100 meters deep. It is used primarily for heating and cooling buildings. Deep geothermal energy, on the other hand, is obtained from reservoirs located several kilometers beneath the Earth's surface. It is used for electricity generation.
The process of generating electricity from geothermal energy involves drilling deep into the Earth's crust to reach hot water or steam reservoirs. The steam is then used to spin turbines, which generate electricity. There are three main types of geothermal power plants: dry steam, flash steam, and binary cycle. Each type of plant works differently, but all involve using steam to generate electricity.
Dry steam power plants are the oldest type of geothermal power plant. They use steam from underground to turn turbines, which generate electricity. Flash steam power plants, the most common type of geothermal power plant, use hot water from underground to produce steam, which turns turbines. Binary cycle power plants use a heat exchanger to transfer heat from hot water to a secondary fluid, which vaporizes and turns a turbine to produce electricity.
In the next section, we'll explore the benefits of geothermal energy and how it can help address the challenges of climate change.
Geothermal energy has numerous benefits, including environmental, economic, and social benefits.
From an environmental standpoint, geothermal energy is a clean source of energy that does not produce greenhouse gas emissions or air pollution. This makes it an ideal alternative to fossil fuels, which are the leading cause of climate change and air pollution. Geothermal energy also has a smaller land footprint than other renewable energy sources, such as wind or solar power, making it more feasible for urban areas.
In terms of economics, geothermal energy can help reduce energy costs and create jobs. While there are upfront costs associated with drilling and building geothermal power plants, the cost of producing geothermal energy is relatively low and stable once the plant is built. This means that consumers can benefit from lower energy bills over time. Additionally, the geothermal industry can create jobs in drilling, engineering, construction, and maintenance.
Finally, geothermal energy can have social benefits as well. In areas where geothermal resources are abundant, local communities can benefit from reduced energy costs and increased economic development. Additionally, geothermal energy can improve energy security by reducing reliance on imported fuels.
Geothermal energy is used in more than 24 countries around the world, with the United States, Indonesia, and the Philippines being the top producers of geothermal energy. Iceland is also a major user of geothermal energy, with almost 90% of its homes being heated by geothermal energy.
The United States has been producing geothermal energy since the 1960s, and today it is the largest producer of geothermal energy in the world. The most geothermal energy is produced in California, followed by Nevada and Utah. The Philippines is the second largest producer of geothermal energy, with most of its geothermal power plants located on the island of Luzon.
Indonesia is another major producer of geothermal energy, with significant resources located in the country's volcanic areas. Other countries that use geothermal energy include Kenya, New Zealand, Italy, and Japan.
While geothermal energy has many benefits, there are also several challenges associated with its use. One of the main challenges is the high upfront cost of building geothermal power plants. Drilling and building a geothermal power plant can cost millions of dollars, which can be a significant barrier to entry for some countries and companies.
Another challenge is the limited availability of geothermal resources. Geothermal energy can only be produced in areas where there is significant heat and water, which limits its availability to certain regions. This can be a challenge for countries that do not have the geothermal resources necessary to produce energy.
Finally, there is a potential for seismic activity associated with geothermal energy production. Drilling and injecting water into the Earth's crust can cause earthquakes in some cases. While the seismic activity associated with geothermal energy is typically small and infrequent, it is still a concern for some communities and regulators.
Researchers are currently working on enhancing geothermal systems to make them more efficient and cost-effective. Enhanced geothermal systems involve injecting water into hot rocks to create steam, which can then be used to generate electricity. Additionally, research is being conducted on geothermal energy storage, which would allow excess energy to be stored for later use. Another area of research is geothermal energy for direct use, where the hot water or steam is used for heating or cooling directly without being converted to electricity. Let's look at another case study of a community that has successfully integrated geothermal energy into their operations. The town of Klamath Falls, Oregon, has been using geothermal energy since the early 1900s. The town's geothermal system provides heating and cooling for over 100 buildings, including schools and hospitals. The system has saved the town millions of dollars in energy costs and has helped reduce its carbon footprint.
The future of geothermal energy looks promising, as it has the potential to provide a significant source of clean energy. According to the International Renewable Energy Agency, geothermal energy could provide up to 3.5% of global electricity by 2050. As technology improves and costs decrease, geothermal energy is expected to become more prevalent, and new geothermal power plants are being built around the world.
In conclusion, geothermal energy is an exciting and promising renewable energy source that has the potential to provide a significant amount of clean energy. While there are challenges to utilizing geothermal energy, such as high upfront costs and limited availability in certain areas, advances in technology and research are making it a more viable option for many communities and businesses. As we continue to seek ways to mitigate climate change and reduce our reliance on fossil fuels, geothermal energy will likely play an increasingly important role in the global energy mix. Thank you for watching our video, and we hope you learned something new about geothermal.